So, when balancing a chemical equation, why do we have to balance it? Well, we have this thing called law of conservation of mass and matter, basically. We cannot create or destroy mass. We cannot create or destroy matter. What we start with, we have to end with. So if I start with 50 grams of a reactant, I have to have 50 grams of product, either in a different form. It can be in a gas, solid, liquid, doesn't matter, as long as we can account for all 50 grams. Okay, so when you're balancing a chemical equation, the thing that you have to remember, and definitely put a star by this, circle it, highlight it, underline, write this down. Subscripts cannot be added. They cannot be altered. They cannot be deleted. Okay? You cannot change them in any way once they're in an equation. Coefficients, this is the next word. Coefficients are the large number that we're going to work with up here. And they are what's multiplied to your subscripts to make our equations balance. Okay? So, step one, and you have this on your sheet. I mean, I don't think, no, you don't have the steps, but you do have these equations on your sheet, and I'm going to walk through each one of them with you. So make sure you bring them to class and ask any questions. Write any questions down you have as we go through it. If you're not sure what I'm doing, ask, write yourself a little note, because this is, if you don't know how to do this, you're going to mess up from here on out to the end of the year. And unfortunately, some of you guys are really, really good at this, and we're in 8th grade. And some of you guys are not real good, but you got to get good at it, or it's going to mess you up on the next, from here until the end of the year, okay? So, when I drew this, we're going to start with H2O plus, or hydrogen plus oxygen gives us water. I drew a little picture here so you can kind of see that it looks like, the way it's written, you can tell that we have two hydrogen atoms, 2 oxygen atoms over here on the reactant side, but over here we have 2 hydrogen and only 1 oxygen. It looks like we destroyed one, but we already know we can't do that, so we have to balance it. So how do we do that? First thing we're going to do is, I like to, step one, divide the problem in half. Reactants to products, okay? Step two, list all of your elements in a row, okay? Start with your reactants. You have hydrogen and oxygen. Whatever you do on your reactants, duplicate it on the product side. Hydrogen and oxygen. Step three, count your atoms. I have 2 on this side and 2 on the side of oxygen. And then over here, I have 2 and 1. Okay, next thing you do is find a coefficient that multiplies times your subscript to make the equation balanced. Okay, so that's the last step. So when you look at it, you start down the row. 2 and 2, they're balanced. But if you look here, oxygen is not. So whenever you multiply, you're getting bigger. So what we have to do is find something here that's going to multiply. So here's how your brain should think. 1 times something is going to give me a 2, because that's what I need. So 1 times something has to give me a 2. And this one's pretty easy. So you look up here, you look here, and you go, oh, 1 times 2 gives me 2. So that changes the oxygen. But think about it this way. Whatever you put here has to multiply to every subscript. And remember, if you need to, write a 1 down next to the oxygen, okay? 2 times 2 is 4, so that changes this to a 4. 2 times 1 is a 2. Never do any math at the bottom. Always do it up here and change whatever your answer is at the bottom. Don't ever do like, what I see a lot of students do is like 2 times 2 down here equals 4, and then they forget something, and you'll see why in a minute. Okay, so don't do that. Do your math up here and then change it down at the bottom. All right, so you go back, your oxygens are balanced, but your hydrogens are not. So you should start thinking, I have 4, I need 2 times something is going to give me a 4. So you put a 2 here, 2 times 2 is 4. Okay, 2 times 2 is 4. Okay. I do not put a 1 here. You can for your purposes, but you'll never see it written that way. It always is a blank because we don't write 1s. But we do have something, and I did not put this up here, and I should have, but it's a mole ratio. We're going to compare the hydrogens to the oxygens to the waters. So these coefficients are called a mole ratio. It's a 2 to 1 to 2 ratio, meaning that it takes 2 hydrogen molecules to 1 oxygen molecule to make 2 water molecules. And that's a balanced chemical equation, okay? All right, so let's go ahead and let's do these. They're on your paper also. If you have any questions, again, remember to write them down so that we can discuss them in class. Okay, so first thing I do, divide it in half. Reactants to products. Step 2, find all of your elements. Duplicate it. Okay, count. 2, 1, 3. You can start at the top. Okay, now this one is a little bit trickier because sometimes you can say, oh, this works. This one actually works, but if it didn't, and let's say these were balanced, then you could start looking at these two. What your brain would say then is that I need 2 times something equals 3. Well, that's never going to happen. It's never ever going to happen. If you multiply anything this times 2, you're never going to get 3. So, because it has to be a whole number for sure. But here's the other thing. You have to think, okay, what could I get as a multiplier or a multiple something you learned in 7th grade, lowest common multiple. The multiple that you're needing is actually going to be 6, okay? So let's go ahead and work with this one. So if I multiply something times 2 to get a 6, I'm going to put a 3 here. 3 times 2 gives me the 6, okay? Then, now I know I have to put a 2 here, because it would be 3 times 2 to get 6. So I'm multiplying that. That gives me a 6. So those are balanced. 2 times the 1 that's not there gives me a 2. So now I'm balanced, okay? So my ratio is 3 to 1. My mole ratio is 3 to 1 to 2. It takes 3 nitrogens to 1 hydrogen to give me 2 ammonium molecules, okay? So far, we're doing okay? All right, I'm trying to keep this video somewhat short, so that's why I'm talking fast. And if I talk too fast and you get lost, please write down some questions and I'll answer them in class, okay? So, divide it in half. Step 1, write your elements down, Na. Oh, there's 2 of them. Wait a minute, don't freak out. Just go to the elements, N and O, okay? What I do here, I duplicate over here, exactly. Don't mix and match. Don't go, oh, I have an NA and O, because some of you guys will go NA, O, N, and look what happens. You can't look across and fix it, and see if it's balanced right away, okay? So, don't do that. What you do on one side, you duplicate exactly on the other side, okay? Now, you count up your sodiums. Well, I have 1 here, plus 1 here. There's the key there, plus. So you have 2. You have 1 nitrogen. You have 3 oxygens. And over here, you have 2 sodiums, 2 nitrogens, and 1 oxygen. So looking across, you see that your sodiums are balanced. Your nitrogens are not. So what could I do to make my nitrogens change? Okay? So what I do first, I'm going to think one time something's going to give me a 2. So if I put a 2 here, that's going to change this to a 2, because 2 times 1 is 2. Here, and the nitrogen, I'm sorry, 2 times, take that back. I pointed to the wrong one. It was supposed to go to this one. 2 times 1 is 2. 2 times 1 plus 1 gives me a 3. Now this is why you don't want to do your math down here, okay? Because if you notice, if you put something times here, it's going to change things. So you want to worry about one thing at a time, okay? So now our sodiums are not balanced, but look at our oxygens. Let's just keep going down and then we'll come back to sodiums. Why? Because you have a free element. And a free element should be the very last thing that you try to balance because it's the easiest to balance at the end, okay? So look at your oxygens. I need something here to multiply times 1 to get me a 3. So it's 1 times something to get me a 3. So if I put a 3 here, And why doesn't this one add up very well? What did I do wrong? Did I do something wrong again? For some reason, okay, so if I put a 3 here, oh no, I forgot to do something. What did I forget to do, guys? I forgot to multiply this. I needed a 6. I did forget one thing. That happens. 2 times 3 gives me 6, because remember what I do to 1, I have to do to all of them. That's where I was going wrong. So it's not a 3, not a 3. I knew I had something wrong. So, see, this happens. Good teachable moment. Okay, so 6. So I need something here times 1 that'll give me 6. 6, okay? So now I have 6 oxygens. Okay, so if you look, my oxygens are balanced, my nitrogens are balanced, my sodiums are not, because now I have how many? 6 times 2 is 12, okay? I have 3 on this side, okay? But I already have 2 of them here, plus something. So here's how your brain should work. I have 2 already, so I have to have 12. So 12 minus 2 is 10. I need 10 more. So what times 1 will give me 10? So it's 10. Okay? So this mole ratio is 10 to 2 to 6 to 1. Okay? It might take a little practice back and forth. Just if you have to draw the arrows, okay? I know this video is probably getting long, but we're going to do this last one real quick. We have iron chloride plus sodium hydroxide gives us iron hydroxide and sodium chloride. All right, step 1, divide it in half. Write down what you have. FeClNa. There is one thing I'm going to tell you right here that I like to do that makes my life easier, but you don't have to. You could go O and then H and work that way. But something I like to do, and I just find it's easier and it's a little bit time saver, is I box in my polyatomic ions if they are exactly the same on both sides. You notice I left the subscript outside the parentheses. I can put a 1 here to tell me that I only have 1 hydroxide. So right here, I would write hydroxide. You don't have to box it, but I'm doing it just to show you, okay? And then on this side, I'm going to duplicate everything I have here. FeClNa, and then I'm going to have the OH. And I'm going to count it as one item, one thing. So I'm going to count it separately, so you'll see in a minute. Fe, I have 1. Chlorine, I have 3. Sodium, I have 1. Hydroxide, I have 1. Iron, 1. Chlorine, 1. Sodium, 1. And hydroxide, I have 3. It makes life easier when you can kind of see that it's not so hard, not so challenging, okay? So I already can tell that I need to change my chlorines, right? My chlorines over here, I have 3 of them. Over here, I only have 1. So I need a number times 1 to give me a 3. So I know that that's going to be a 3. When I do that, it's going to change this chlorine to a 3, and this sodium to a 3. Okay? Over here, I can see that I need to have the sodiums balance out. So if I put a 3 here, changes my sodium. But guess what? If I multiply it times that 1 that I know I have of hydroxide, now I have 3. So my ratio is a 1 to 3 to 1 to 3 ratio. Okay? So bring this to class. I think I'll have one more on this page for you guys to do on your own, and bring it to class, see what you got, and come with questions if you have them.